Welcome to the AxisVM frame model video tutorial. The frame will be designed under the Eurocode standard. In AxisVM, create a new model. Set the model file name to frame, select Eurocode from the design codes, and set the units and formats to EU. The geometry of the frame will be created using the editing tools. This can be done in several different ways, but in this example, we will be using the Draw Objects Directly function. To first create the columns, click on the Draw Objects Directly icon on the Elements tab, and then select the column icon. In the window that appears, select Browse Cross-Section Libraries. Another window will show up. Scroll down in the list of cross-section tables, select HE European Wide Flange Beams, and then click on HE 280A. A warning message will appear. After clicking OK again, scroll down in the list of materials and select S235. Then click OK. The selected cross-section and material are displayed in the Draw Objects Directly window. Now set height to 3.5 meters in the window. Make sure the view mode covers the XY plane, as we will place the columns in a top view. Click on the column icon to place the columns. Create 3 frames that are 6 meters wide in the X direction and 5 meters apart in the Y direction, as shown. Change the view to perspective, and in the window menu, activate perspective settings. Set the following parameters. H equals 15, V equals 320, and P equals 0. Then click on the horizontal beam icon. Click on the cross-section row in the window, and then on the Load from Database icon. Select IPE 400 from the IPE European I-beams group. Close the window with OK. The selected cross-section is now displayed on the panel. Activate the Beam Polyline icon, then click on the top of the columns and draw the axis of beams as a polyline. Draw the perimeter beams first, then press Escape to cancel drawing, and finally draw the inner beam. Now change to the Beam function on the panel. Click on the cross-section row in the window, and then on the cross-section library import icon. Select Pipes, and then O-Hungarian Pipes. Find and select O194 by 5 SV in the list. Draw a polygon from the bottom node of the front right column to the center of the beam as shown. Continue drawing to the bottom of the next column. Press Escape to close the function, and then repeat drawing for the other side of the structure. Now, the entire structure will be copied into the Z direction to define the upper story. Activate the Translate icon. Select all of the elements, and in the Translate window, select the Consecutive and None checkboxes. After clicking OK, click on the bottom node of one of the columns, and then on the top node. Press Escape to close the command. Select Zoom to Fit for a better view, and then select the rendered view from the view modes. Activate Display Options. Uncheck Object Contours in 3D on the Symbols tab, then close the window with OK. Change back to the wireframe view. To create nodal supports, switch to the Elements tab and click on the nodal support icon. Then select the bottom nodes of all of the columns and confirm by clicking OK. In the next window, the stiffness can be set for the supports. Set the rotational stiffness components to 0, but leave translational stiffness on the default value. To specify the loads on the frame, switch to the Loads tab. The various loads should be separated into load cases. Click on the Load Cases and Load Groups icon. In the window, click on the name ST1 and rename it Live Load 1. Close the window with OK. The active load case will be indicated on the info palette. Add line loads to all of the horizontal beams. Activate the Load Along Line Elements function and select all of the lower level beams. Confirm the selection with OK, and in the window, set the load parameters. Set PZ1 and PZ2 to -50 and then click OK. The load will be indicated on the beam elements. Repeat the process now for the upper level beams and set PZ1 and PZ2 to -25. Then, click on the Load Cases and Load Groups icon. Add a new load case to the list and rename it Wind. Click OK and the active load case will be replaced with Wind. Click the Load Along Line Elements icon and select the corner columns on the left side of the frame. Now apply a 6 kilonewtons per meter line load in the x direction, px1 and px2. Similarly, apply a 12 kilonewton per meter line load in the x direction to the central column on that same side. Now create a load combination on the basis of the load cases. Activate the Load Combinations icon and in the window, create a new Ultimate Limit State load combination. Assign 1.5 to both load cases Live Load 1 and Wind. Click OK to finish inputting the data. Activate Display Options and on the Symbols tab, uncheck Node, Cross-Section Shape, and all of the load checkboxes, then close with OK. Now, click on the Static tab and then on the Linear Static Analysis icon in order to run the analysis. Click on Statistics to see more information about the analysis, and then close with OK after the analysis is completed. The static tab is automatically activated with EZ millimeters vertical deformations for the live load 1 load case displayed in the ISO Surfaces 2D view. To see the results of other load combinations, select combination CO number 1 from the drop-down list. Then change the results view to diagram and the overall view to the XZ plane. Define parts to see only specified parts or elements of the entire model. Click on the Parts icon, then click New, and enter the new part name as 1. Finish by clicking OK. Select the elements on the right side of the frame which will be defined as Part 1. Finish the selection and close the window to create the part. Then change to the YZ view. Click on the Result Display Parameters icon and check the Right Values to Lines checkbox in the window. Close with OK and the min-max results will be displayed on the line elements. To find the location of the maximum deformation, click on the min-max values icon and select one of the deformation components in the window. The software will show the maximum negative value and its location. Clicking OK will show the maximum positive value and its location. Select Beam Internal Forces NX from the drop-down menu, and the display will show the results for the NX component. Change the result component to MY to see a bending moment diagram. And finally, select Nodal Support Internal Forces RZ. Now we will conduct a steel design of the column members in accordance with Eurocode 3. Firstly, design parameters should be assigned to the corner columns. Click on the Design Parameters icon and then select all of the columns in the corners. Confirm the selection with OK and specify the following in the Design Parameters window. Set KY to 1.25 and select the Auto MCR method to calculate MCR. Close the window with OK. Then in the drop-down menu, select Analysis, NMV Axial Force Bending Shear. Select Limit States, Utilization ULS, from the same drop-down box. The back lower right column is not safe for the load combination because the maximum utilization, 1.131, exceeds the value of 1. This design error will be corrected by using the optimization function. Click on the lower front right column to see the results of all of the checks. Click on the Design Calculations icon to see detailed calculations which can be printed or added to the documentation setting. Close the report with OK and click OK again to close the Steel Design member window. In order to optimize the cross-section of the columns and correct the design error, click on Steel Cross-Section Optimization. In the window, click on the New icon to specify a new optimization group. For the group of lower columns, enter the name Lower Columns. Close with OK and select the 4 lower columns in the corners. Finish the selection by clicking OK and the window will show up again. In the Library tab, select the cross-section groups and add them to the list of candidates for optimization. From the list of eye shapes, select HE European wide flange beams and add to the list on the left by clicking on the blue arrow between the 2 list boxes. Now, create another optimization group for the upper corner columns. Provide the name Upper Columns, and then select all 4 upper corner columns. As before, add the HE European wide flange beams shape group to the list of candidates. Now set the objective of optimization to be minimum weight and set the maximum utilization to 0.85 for both optimization groups. Then, by moving to the Optimization tab, the specified optimization groups and present utilizations of the cross-sections can be seen. Clicking the Optimization button will start the calculation procedure. A warning message will appear, but click on Yes to continue. When the optimization process is complete, the suggested cross-section will be displayed under the row of the current cross-section. Considering the specified parameters for optimization, the software suggests we apply the shape HE260A for the upper columns and HE400AA for the lower columns. In our example, only the lower columns will be replaced. To replace the cross-section, click on the Replace field on the row of lower columns, and then click the Replace Cross-Section icon. In the following windows, click No to keep the original file name, and then Yes to save the model. After changing the model by replacing cross-sections, the model must be saved and previous results for the static analysis will be deleted. Now on the Static tab, run a new linear static analysis. Back on the Steel Design tab, check the utilization of the design members. Since every member is safe after the strengthening, the optimization can be finished. In the figure, you can see that the maximum utilization of the critical member of the lower back right corner is now 0.928 after modification. Note that this result is greater than the value that was previously set for optimization. This is due to the changes in internal forces after modifying the column cross-sections. Thank you for watching. Please visit the AxisVM website for further information and additional tutorials.